I've just given you homework number 11. The next assignment you have due is for Tuesday. And that includes some questions from both Chapter 11, which we're finishing our coverage of today, and also Chapter 12, which we're going to take on Sunday. We're going to continue talking about replacement and retention decisions today with an in-class exercise. Any questions on the announcements or where the course is headed before we get into it? All right. This picture kind of tells a story of old equipment versus new equipment. And on the left you can see it's at a power plant. This photo was taken in the 1970s. Control equipment that's measuring the RPM of turbines and the frequency of the alternator and so on. And on the right side is a new system that's called SCADA. And SCADA is used in a lot of different industries. It's included water, electricity, and the idea being that you put computerized controls on every part of a process, and so you can control it and observe it and monitor what's happening in the process in a central location. So when we decide whether we want to invest in a new system, whether it's control systems or navigation or whatever the case may be, our objective is to minimize costs. And just to review a couple of assumptions that we've discussed previously, when we're comparing a Defender and a Challenger, both may generate revenue, but we ignore that in the replacement study analysis. What we need to focus on is just the differences between the two. And so we consider that both of them have the same specifications, the same level of productivity, and if that's not true, then we add additional costs to the weaker item to make sure that it has the same capabilities as the stronger item. And so if our Defender is an older piece of equipment, put in additional costs to the Defender, maybe additional maintenance or calibration costs, whatever is required to make it equivalent to the Challenger specifications that's being considered. Today we're going to consider the case of both when no study period is specified and when there is a study period specified. And there's a different way we proceed for both of those. If the study period is specified, usually what they're doing is they're saying that the new equipment, the Challenger, is going to last for a longer period of time than the Defender. And so we have to use one of the methods that we already learned about to make them last the same time. So do you remember when we had equipment and maybe one of the items only lasts for 2 years and then one of the other items lasts for longer, and we want to compare these items? What are some of the ways we can compare item 1, which has a short life, with item 2 that has a long life? Yeah? Excuse me? Repeatability. All right. We're going to use that. That's true. We're going to use that assumption less often in replacement studies, because when we begin a replacement study, remember that the Defender is a piece of equipment that's used already. And we're trying to decide whether we should keep it. And so we have this old item that will only last for 2 more years. It's difficult for us to obtain the same old item and own it again for 2 more years. We could go get something similar, but we can't buy the same item that we're choosing to retain. And so it's kind of a variation on repeatability that we're going to end up using, but it's not exactly repeatability itself, because when we used repeatability before, we're usually starting at year 0 with the initial purchase of the item, and that's not the case in a retention study. What are some of the other things that we did to make them the same amount of time? Yeah? Early termination, right. So we would sell this longer item early and get more of a market value, just to compare how the 2 different items perform. Very good. Another option was contract services, where we could go and use a subcontractor and pay them a lease payment or a fee to do the same work until the contract study period is over. And there's one more final variation, and that's what we're going to do today, is here in drawing 1 versus drawing 2. Drawing 1 is the Defender. And Defender is the old equipment, and then the Challenger is the new equipment. Usually, when we're deciding whether to keep the old equipment, in our mind we're thinking at the end of that equipment we're going to buy the Challenger because it's the best option except for the thing you already own. And so what we'll sometimes do is we'll take a look at the end of item 1's life, then we buy the Challenger. And so we're kind of combining the cash flow diagrams together. You have the Defender followed by the Challenger. And we're going to do a variation on that in today's in-class exercise. We're going to begin with a replacement study where there's no study period specified. The problem statement itself isn't telling us how long we have to have the equipment for. It's more naturally derived from the economic service life. Economic service life is what we did last time. We're going to create an economic service life analysis today for 2 different items. Once again, I've put an Excel file onto iLearn. So you're going to need to log into iLearn, go into the class notes folder, the other items subfolder, and there's another Excel file there similar to what I gave you last time. Open up that Excel file, and what you'll see is I've already done the economic service analysis for the Defender, and you need to do it for the Challenger. Our criteria, how we decide, is you pick the alternative that has the lowest annual worth cost, even if those two have different lifespans. So for the Defender, it may say that the cheapest alternative with the Defender is to own it for 1 year, and the cheapest option for the Challenger is to own it for 5 years. It's okay that those are different lengths of time because in this study, no specific period has been specified. So this is the first kind of analysis we're going to do. Usually in a case like this, you would pick whichever has the lowest cost, go with it for the amount of time that is described, but things can change. Equipment can age more quickly than you anticipated. The Challenger might go on sale. And so the text makes the point that you need to do follow-up studies every year that you continue to use the old item just to make sure that it continues to be the best option. And so in the homework problems, as I went through the back of the book and was trying to pick which homework problems, I noticed a lot of times those problems were about changes in information. You know, if equipment is holding up better than was expected, or the equipment is maybe aging more quickly than was originally anticipated. And so when we are projecting into the future, we're at year 0, and we're trying to guess what the costs will be in year 5. Sometimes we don't do a good job predicting the future. We're not fortune tellers. We don't know everything that's going to happen. So as you continue to use the Defender, you should perform a follow-up study every year. All right, with that, I'm going to turn on the lights and let's get started on in-class exercise part 1. Does everyone have a copy of the handout? Part 1, the question is telling us that a company is choosing whether to replace a robotic system. The existing equipment, meaning the Defender, currently is worth $15,000. Can anyone remind me why we consider that as a first cost? Why is the current market value of the Defender chosen as a cost when we do our ESL? Yes? Exactly. He said it's an opportunity cost because if we keep the item, we don't get to sell it. And so that's what we have to think of as the cost of keeping the item. If you go with the equipment you already own, you lost the opportunity to sell it. And so the current market value is its first cost. And it says in the problem statement that the current market value declines by 20% each year. And so that means in year 2, it's worth 0.8 times the value in year 1. And in year 3, it's worth 0.8 times the value in year 2. Each year it's going down by 20%, or it keeps 80% of its value every year. And we have operating costs that are specified. So that's the Defender. The Challenger has a first cost of $50,000. It lasts for 6 years, and the market value is also declining every year as described there. So go ahead and get the the spreadsheet file and get started with the economic service analysis for the challenger. Okay, I want to show you a small trick that might save you some time. So when we're doing column D, it's a little bit annoying because you have to type in the formula every time, right? Let me just delete this one. So if you have to do the formula every time, equals NPV, and then you click on the rate up at the top, comma, and then you have to highlight the range, and then enter. So I guess it's not that bad. But if you just drag down from the one above it, it makes a mistake because it doesn't know the correct range. But all you have to do is correct where it's selecting for the range. So if you drag in the selection box, then it makes the update for, well, hold on a second. Let me make sure that it got the right. Oh, and I should have anchored the interest rate as well. Yeah, so whenever it's looking in the wrong spot, you can just drag it down to the correct spot, like that. So the point is you can still not be, so let's see, oh, first cost, yeah, so put it up here to the interest rate. So it would save you from typing the NPV function so many times. There we go, now it's fine. So when you're starting at the top, if you just type it in once and then drag it all the way down through, oh, type it in once with the anchoring of the interest rate, and then you drag it down every time, and then you can make the correction of where it's looking for the range of cells. Like here it's only looking at 7,000, so you would drag it up to look at both of the numbers. And the next one, drag it up to look at all three, and so on. Yeah, just a moment. Let's take a look at the solution here. Okay, here's what we know about the Defender. Right now, today, it has a value of $15,000, and so we consider that as a first cost because if we keep it, we can't sell it. And so there's an opportunity cost of $15,000. Here is the declining market value of the item in each of the years, along with the operating costs that have been specified. How do we know what the market value is going to be in 3 years? It's just an estimate. It's our best guess based on other similar equipment that's available and us taking a look at how it's aging. So we've already taken a look at how to do the PV of cumulative operating costs function. Once we have all those, we use the payment function to find the annual worth of the operating costs. Capital recovery is that function where we're considering the difference between the first cost and the market value at whatever the N is for the row we're on and the given interest rate I. And then finally the column G, I should correct this, it's E plus F. Okay, it's the sum of the two columns to the left of it, the operating costs and the capital recovery. Okay, so for this option, for the Defender's option, the best thing for the Defender is to keep for 3 years. Oh, well. There we go. Oh, boy. All right. Now for the Challenger, doing the same thing, it looks like the best option for the Challenger would be 4 years, and now we compare the two. No studies period is specified, and so we can either keep the Defender for 3 or keep the Challenger for 4, and of the two, the costs are lower if we keep the Defender for 3 years, and so our final conclusion is keep the Defender for 3 years. Now, a couple of things we need to mention along with doing this analysis is that we would come back and revisit everything in 1 year. we'd go into the market and we'd find out what's the current market value, what's the current cost of the Challenger, and keep redoing the analysis every year just to make sure that the circumstances are still the same. But based on our assumptions, it currently looks like we should keep the Defender for 3 years. Yes? That means if you bought the Challenger, the cheapest thing to do would keep it for 4 years and then get rid of it. All right. The next problem is not with Excel. This is a paper problem. And it is the kind of issue where we have a study period that is specified. We're going to prepare a cash flow diagram for the Defender and the Challenger. In fact, I've already done that on the in-class exercise paper. And the study period in this case is going to be the life of the Challenger that we're considering, which is 10 years. And what we're going to do, because the Defender doesn't last as long, since the Defender is old equipment and we're going to retire it after a shorter period of time, what we'll do to make the Defender go through the entire study period is we're going to purchase the Challenger at the end of the Defender's life. Okay, so let's get started on part 2. On this one, we're doing it on paper, and I've given you the table lookup factors on the back side of the paper. But here's the situation. It's a navigation system, and we have to decide whether we should keep the Defender or buy the Challenger. And the cash flow diagram is a little bit messy. Let me zoom in on the cash flow diagram just so we can talk about that. The Defender is pretty straightforward. If we buy the Defender, what it means we're going to do, if we buy the Challenger, here we go. If we buy the Challenger, then that requires an initial payment of $750,000 and then has annual operating costs of $50,000 every year. Okay, so that's the first thing. And what we need to do is find out what's the average annual cost of that. So we're going to have to take the $750,000 and spread it out over 10 years to find the average annual cost, a total annual cost. Okay, the Defender, the existing equipment will last for years 1, 2, and 3. While we have the old equipment, maintenance of it is going to cost $30,000 a year. And its current market value is $70,000. So you can see I've marked those two things as item 1 and item 2 on the cash flow diagram. After that wears out, then we have to go buy the Challenger. And we estimate that the Challenger that would have cost $750,000 if we bought it today, if we buy that item in year 3, it's going to be $900,000 because prices are always going up. And CR that's shown here, Series 4, that is the capital recovery of the first cost of the Challenger. So take the $900,000 and spread it out over 10 years. That's what capital recovery is. These last two lines are because we're going to transfer the item to a different project for the last 2 years of the project. And so these dashed lines means we do need to find out the amount of the capital recovery, but our project isn't going to cover the cost of it. And I know this is kind of a complicated example, but it's one that comes from the text and I think is good for us to take a look at because life itself is complicated. We aren't always going to have simple economic analyses we have to do. So what we do is exclude the last 2 years of the capital recovery. And finally, item 3, as you can see that there is an annual operating cost of $50,000 every year we have the Challenger in service. So we need to take all of these 4 components and spread it out over 10 years. Yeah. You spread $900,000 out over 10 years, but then the last 2 years you forget about. So then you really only have 1, 2, 3, 4, 5, 6, 7 of them. How many years is it again? 10-year life, but we only use it for 7 years. Okay, there's 2 more that aren't shown here on the figure because we keep it for 1, 2, 3, 4, 5, 6, 7. Yeah. So we have spread it out over 10. We keep it for 7, and then you take the 7 and spread that out over the 10. So you'll have to take the 7 to year 3, from year 3 to 0, and then from 0 out over 10. All right? This is going to really take you back to the olden days when we did a lot of these cash flow diagram transitions. So basically, we want to have an annual series where every amount, years 1 through 10, is the same. We want to find out the average annual cost, years 1 through 10, for those 4 components. And just draw one more line here next to the 2 that I've got already, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, but it actually has a life of 10 years. So draw one more dashed line using your pencil onto the paper. Okay, we're done with Excel for now, so focus on your paper calculations. No, do everything with the table lookup factors. All right, so we have 2 options, the Challenger and the Defender. As I already mentioned, the Defender has 4 components. The Challenger is easy to do. The annual worth of the Challenger is $172,000. That's a cost, so that's why the negative sign there. So you need to find the annual worth of those 4 components. Okay, component 1 is already at the present, so I just leave it as $70,000 at the present. Component 2 is the $30,000, so I take it to the present. That turns it into $74,607 at year 0. Component 3 is this annual cost of $50,000. So how we handle that is you take it to year 3. So you take the 7 years to year 3, from year 3 to year 0, and then spread it out over 10 years again. So those are the steps you can see here. I take it to year 3, then take it to year 0. So that's 50,000 times the factor for taking it to year 3 and then to year 0. So that turns it into 182,000 at year 0. The 4th step is the one that's really complicated. So we have to take the, I'll leave it on this screen. We have to take 900,000 at year 3 and spread it out over 10 years. That turns into 146,475 per year. 7 of those are included in our study period, not all 10. And so I take the 7 years of that and move it to year 3. So that gives us $713,000 at year 3. Move it from year 3 to year 0, and that's worth $535,000. So finally, the 4 components are 1, 2, 3, 4. All of that's money at the present, and the last step is to convert it into an annual worth. So the Defender is the better alternative because it has the lower cost. If we looked at the Challenger had a cost of $172,000 per year. The Defender's cost is $140,000 per year. So we should keep the old item as long as we can, and then purchase the Challenger in year 3. If this example doesn't make sense to you yet, I'd really encourage you to keep working on it, and then watch the recording if you needed. Also, this same example is in the book. This is one that I've taken from the book and tried to simplify a little bit compared to the way that they present the example. But if you'd like some more exposure to it, I'd encourage you to take a look in the text. All right, that's it. I'll see you on Tuesday. Stay tuned for the location. No, not Tuesday. Sunday. I'll see you Tuesday, but also before that, I'll see you on Sunday. I'll send a message on the location. I'm not sure if we'll be back in here yet.